Hello, everybody. This is Jay and Kelly, and welcome to our first of 5 master classes that we're having for Wheatstone. These classes are designed for existing Wheatstone clients, the high-level clients, the low-level clients, the engineers that may have come into a WheatNet facility that don't know what they have, want to understand how things work, maybe get underneath the hood. We've got some things like disaster recovery planned, and a little bit of sales, talking about our redundant links and some other great options that we have, which have actually been enhancements to our product line. So what we're going to do today is we're going to get into our presentation. So let me share my PowerPoint with everybody. And if you have any questions during the presentation, please put them in the chat box. And Dee will, at the end of the presentation, Dee will go ahead and read all those off to all of us today. So if you give me a sec, we'll start right now. And first thing we're going to talk about is the high-speed highway for AoIP, and sort of what AoIP is and what it means to the broadcast facility, what we're doing with the AoIP stuff, how it works, how it interacts with the switches. When somebody's never worked with WheatNet before, or any AoIP, because a lot of things we're going to talk about today apply to everybody else's stuff as well. When they ask me, what is WheatNet? They come and they see the shiny boxes and they see the console. And on the outside, it looks and acts like any traditional console routing system. But as you know, over the years, we've migrated from all of our own hardware and TDM routers and backplanes to Ethernet-based devices. And what we use to deliver this high quality, low latency audio to and from our hardware to mixers and eventually out to the rest of the world is multicast. And for the guys that know networking, they understand multicast. For people that have never worked with multicast before, and they ask me, the salesman's pitch is multicast is gremlins on your network. Your bandwidth is food, and don't feed them after midnight. It is a different beast in itself. And when somebody talks about multicast, they worry about flooding and they worry about all these other things that were associated with early versions of AoIP. Well, we've followed a lot of standards. We adhere to things like pruning and stuff. But because in radio and television, we have to use a multicast because we don't know what we need where, when. Unlike unicast, you've got a mixer at your local bar, and you've got a band that comes up and we're just sending, signals from a stage back to a soundboard. Unicast works great for something like that. But when you're in a dynamic broadcast facility and you've got dozens of codecs, you've got lots of different studios, you've got multiple control rooms controlling studios, we need to be able to send anything everywhere whenever it's needed. And so multicast is the best form of transport for that. But when somebody thinks about multicast, one of the things that they actually worry about is everything everywhere. Well, that's where we get into the whole managed switches and infrastructure like that. So what I'll do on our next slide, if I can get to the next slide, there it is, sorry, is we're going to talk about how we actually manage that stuff. So one of the first things people talk about with Wheatstone is they say, well, you guys recommend Cisco. Yes, we recommend Cisco. You can use, we have some large customers using HP, Arista. If you're a big nationwide network and you want to send audio from blade to blade, the excess of 75, 80 miles, yeah, you're going to need a really good network, but that's possible. What makes all that work in your switch or your Ethernet backplane is 2 big things, IGMP and the querier, okay? When you get a Wheatstone system or you're going to build your infrastructure for Wheatstone, every one of us manufacturers has a little simple set of instructions that you need to tailor your switches for multicast or your operation, whether it's VLAN, stacking, trunking. We're going to talk about that later on. But there is a subset of things that you're going to have to use to manage that within your network. And I look for our presentation today. Wheatstone has about 10 key things that the customer can program. We do that for you if necessary, but about 10 key things that you've got to type in command lines into these switches to optimize those for Ethernet audio. So when we're talking about that, but out of those 10, 3 key things come to mind for us. One is the IGMP, one is the querier, and one is the TCN flooding. And we'll talk about those individually. The querier is the traffic cop. If you, and when I said that the multicast is gremlins on your network, each WheatNet stream can be up to 5 meg. You get 30, 40 blades, hundreds of inputs. You're talking about a lot of bandwidth at quarter millisecond packets arriving from point A to point B in less than 3 milliseconds. So to do that, we have the querier. And by enabling that querier, he's only sending, or she's only sending, or it's only sending information or the data or multicast where you want it when. So if I have my audio console and I'm dialing up on an X controller on my console and I want to take a tie line codec and I want to route that to channel 3, well, at that point, the console is the receiver. I'm going to dial up the source that we need. I'm going to click take, and that switch is going to grab that audio from that blade and it's going to join that together. It's not going to send that tie line codec to port B or D or across VLANs or anywhere else. It's going to be point to point. And without that querier, you'll run into flooding. And the biggest part about why we say managed switch, because it's the management part. It's what we can do with these high-level switches, set queriers, set the TCN flooding, set the IGMP, all the parameters that we need, whether it's an access port or it's a trunk port or we were working with VLANs. That's what really makes all this work, is the IGMP and the querying. That's what keeps everything quiet and where it needs to be. Wheatstone takes it one level farther because it's our hardware, it's our protocol, it's our drivers. And what you'll find in many multicast systems is they're always going to be sending audio to outputs, destinations. They're like, hey, do you need me? Do you need me? One of the neat things about WheatNet IP is we actually prune that network. So if you've got a bunch of unused outputs sitting in your rack room or outputs on the mic blades that you might be only using inputs on, once everything comes up and the querier starts checking and asking who needs what, we actually pull those streams back. So that will decrease the overhead and the CPU usage in our system. So, that's WheatNet specific. When you get into the AES 67 world or maybe other protocols, that's not true. So in the Wheatstone system, the IGMP and the query are the main things that make it happen. The TCN flood, okay, this is native in your switches. Some switches had issues early on with this, and anybody that's out there now, and I can think of my friends at Bonneville, Seattle, for example. Every time they pulled an access port or they were adding a edge switch or making a topology change in their system, it was breaking the audio. And I remember specifically Steven calling me up and saying, Jay, every time I do this, it hurts. And, like the doctor, I said, well, don't do that. But ultimately what it was a bug in their system. But when we program switches, or if you look, and this can be also found in our swag bag that we have here after the webinar, but it's a simple sheet on how we set these Cisco switches up. And if you want to use different switches, if they adhere to the IGMP protocols or they have their own version of IGMP and querying, there's a good chance you can use those. We technically say Cisco by default because everybody here at the company knows them extensively. We know how they behave and it seems to work well. But whether we're configuring a trunk port or an access port, what we will do is we will turn off this TCN flooding. It basically, whenever you make a change, and when you unplug that cable or you add something to the network, it's going to force a topology change. And then Cisco by default is going to flood every port. In the AoIP world, what this results into is dropped audio. It'll sound like it broke all the connections and made them again. You might get an extra pop or two, So what we recommend is anybody that's using Cisco, if you haven't enabled this into your system, it's really because the nice thing about these AoIP systems, they're scalable, unlike our TDM counterparts. You can make them big, you can make them small, you can add switches, you can add blades. It's really nice. But if you don't use this TCN flooding ignore command, what will happen is you'll have breaks in your audio and it's just unpleasant. So did I miss anything on that?
That covers it.
Okay. Again, why does this matter for WheatNet? Because we are putting lots of data on a link. We're sending it sometimes several kilometers, meters. And with this querying and IGMP everything, it makes and works just like anybody else's system. So it's really the foundation. We make these high performance devices. They live on your network. It's your network. And if it's tuned and set up properly, it'll just run and you'll have great performance forever. On that, the switches are only as good as the cables you connect them with. Okay. Unfortunately, cabling is still one of the weak points in this industry. We can tune these switches and we can set everything up. But if your infrastructure is lacking in any way, shape, or form, multicast and AoIP will definitely exploit any of that. So if you're having, we recommend you use good connectors, good cables, certify the cables if possible, make sure they're tested. A lot of us manufacturers have tools in the background that we can tell when we see things coming and going or dropping off the network. But ultimately, WheatNet is a bunch of hardware and software that we give to you to put on your network. So making sure that that network is solid and up to snuff and performance ready. Simple programming in the switches. Here's a few topologies, just a short video here that I'm going to play before we get into the next session. And again, everybody's different. Some people want to use centralized routing. They want to have one or two switches in the center. They want to wire everything to it. Some people, we can't do that because of distance, so we run fiber to edge switches. Trunking is very popular mid small markets. Anybody that's using 100 blades or more, you're going to be definitely a candidate for StackWise. And we're going to talk about the difference between access ports and StackWise and trunking and things like that coming up. But these are real life systems that are out there and basically give you an idea how everything's connected, what people are doing and how people are using WheatNet. A lot of them will look the same. We found some really good recipes that just work. We got good topology, good hardware matches, and everybody's different. Unfortunately, budget comes into play with most of these systems. It depends which market you're in, how much IT infrastructure you already have in place. Do you have IT? WheatNet and the Axia guys, the Lavo guys, what we did is we really, by putting out these systems, we really melded the IT and the broadcasters together. I mean, at the beginning, it was terrible. All right. I mean, luckily now most of our customers are IT savvy enough, or if they're not, they have help. They've got corporate help, they've got local help. Um, we recommend once you get your WheatNet network set up, you get it running, you get everything plugged in, it's usually a set it and forget it. Now, like I said, one of the nice things about WheatNet or any of the IP tech is it expands and contracts really easy. It shouldn't be invasive in any way, shape, or form. So, that's one of the things. I don't see people getting into it a lot. I don't think people checking for updates, although that's changed a little bit. So, what we're going to do now is we're just going to go through different topologies. I'm going to tell you some pluses and advantages of topologies. We'll talk about connecting these later on. So, Old Faithful. If you're a mid and small market, you've got an on-air studio or a production studio, 5-6 blades here or there. You don't have a big budget. I would probably recommend you start out on a simple single VLAN system here, a simple core switch. We wire everything to the core switch. Everything just tends to work. if you have to, well, if you have distance issues, or you've got a studio where you might have 5 or 6 talent stations, 3 or 4 blades, a control surface, it may not make sense to run 8 or 9 Cat 5Es back to the rack room from the studio. At that point, what we're going to recommend is you place an edge switch. 3560s, C1000s, they've changed over the years. The nice thing about the edge switch is that you just run one cable from point A to point B, and then you've got an isolated studio. And that's another thing that the edge switch gives you. One of the advantages of WheatNet is because it's Star Trek Borg-like, the whole thing doesn't need to be connected all the time to work. So this gives you maintenance windows. It gives you failover recoveries. So if you've got a studio hanging off an edge switch and all your local sources are there, and you've got an output from that room hardwired to a transmission path or a codec, you can sever that edge switch and that whole little system will break apart and run fine. Later on, I'll talk to you about that when we have power ups and power downs. Back to here. When I show a traditional broadcast engineer this setup here, they look at that 9224 port and then they think it's a lot of eggs in one basket. And they ask me, Jay, what happens when that fails? And I said, your audio stops. But we will have backups, ways around that switch, maybe take digital outputs from the blades or analog outputs, wire them directly to the STLs or the backup audio sense on a processor. So if we lost the Cisco, we had audio coming out of the blade, it would then sense that and it switched the air. But you don't have to do that. You can actually add 2 switches. So here we would use an access port or trunk these 2 ports, these 2 core switches together, and then we'd build our edge network off of that. One of the nice things about this topology, and we at Wheatstone try to intend to work with our clients in this respect, that if you're going to have a total of 20 devices, I'm going to recommend that you buy 2 24-port switches. We're going to half load each of those switches. We're going to load them and distribute your losses properly. If we got 2 stations, one station on one switch, another station on the other switch. One production room on one, another production room on air. In the case of a failure, you simply move the cables from core 1 to core 2 or vice versa, and you can be up and running. Obviously, there's a cost associated with this. We're going to talk about that later on and where it makes sense to save money and where it doesn't make sense to save money. On a bigger system, all right, as I mentioned earlier, if you have 100 blades or so in a system, you tend to have a big rack room. And when you have a big rack room and you've got multiple core switches, and we've got sites with up to 7 or 8 core switches, if you look to the right-hand side where my mouse is, this is what's called stackwise. Instead of the traditional trunks or the traditional access ports where we're going point to point, what these stacking cables do is they link every switch together, creating one high-speed backplane, one CPU, but you also have a ring type topology where if you have a failure right now in switch 2, everything on switch 1 and everything on switch 3 is going to work. So again, if you had a hardware issue, you go in there, you pull the RJs out of the switch that's not blinking into the switch with blinky lights, and in a few seconds you're up. But what the big advantage of Stackwise is connecting those big backplanes, because when you get 100 or so blades, it's a lot of audio. And again, you want to create the best possible route to get those audio signals in and out of, through these switches, in and out of the edge switches, out to your transmission. Okay, so I've been talking about the access ports and the trunk ports. Again, it's your network. If you call me and you're not an IT savvy guy and you say, Jay, I need to replace my analog stuff. I'm a Zeta user. What do you recommend? I'm going to say, I want to give you an isolated network. I want you to put our devices on it. I want you to dual NIC your Zeta machines, and this thing will run forever. We'll talk about, 1 or 2 core switches, edge and stuff like that. But I will tell you from a maintenance standpoint of view, one of the easiest things and the things that we have the least trouble with are the guys that are just have a dedicated Wheatstone network. All right. And those tend to be the mid and small markets, mainly because the talent. When you get into doing VLANs and stuff like that, it takes just a little bit level of networking. And, not everybody's ready for that. But I will tell you, if you have a simple system, you're on one VLAN, you can use access ports from switch to switch, blades to blades to switch, surfaces to switch, all of our talent panels, and it just works. Pretty simple setup. And if you're a mid or small market guy, recommend you do that. VLANs, the guys that know how to do them, they work great. You definitely benefit because you're maximizing your hardware. You can buy a large switch. You can use a portion for one thing. You can use a portion for other. Or you're on a corporate network. Okay. We've got Cedar Rapids, we got Missoula, we've got Dallas, we've got Utica, New York. All of those are connected. Okay. You're going to be doing VLANs or you're going to be using trunk ports and routers and servers. That is the main two ways that we connect WheatNet. All right. I have stacking in here because it has really nothing to do with the trunking or anything like that. Stacking is just creating one large backplane for your larger WheatNet systems. And then again, you can stack a big core and then you can VLAN that whole thing as well. It really comes down to what you're comfortable with. Again, I will say for the bigger systems out there, 99% of our clients have got 3 or more switches using Stackwise technology. And to the best of my recollection, they all love it. We never have any performance issues, and it seems just to work. But again, you've got to use good switches. It doesn't matter your topology. You still got to do the IGMP, the querying, and the TCN flooding. And especially if you're going to be trunking things together, because now you've got other people outside your broadcast area plugging things in, printers, links, Town Square, Trenton, I think, got their whole AoIP system taken down by a ubiquity wireless AP.
One AP, a single AP.
Yeah, crashed your entire network. So I always tell people, and I joke, guys, I'm not a broadcast engineer. I don't own a big WheatNet system, and I don't make money on a WheatNet system. But when I see these guys doing VLANs and stuff, and they do work, I always say, I'm like, you're one bad patch. You're one bad patch away from being off air. And up to you. It's your system. But at the end of the day, the network is the single most important thing about anybody's AoIP stuff. You can have the best gear in the world, but if you can't get from A to B in under a few milliseconds, or you've got a lot of jitter on your network, you're going to hear it. So it's just something that you should adhere to. And if you don't know, ask. Every one of us manufacturers now have to deal with this. I can tell you we don't want to deal with it. We don't want to be your network support. But when it comes to the Wheatstone stuff, we've got enough experience and we've dealt with enough. We can definitely point you in the right direction. I think we actually put this up in the swag bag. So after your presentation today, there's a link that will provide you where you can grab some configuration sheets. I think we've put this up here, but this is something for you to look at and say, okay, I've got a system. I've got this Wheatstone system I walked into 2 years ago. It just works. I don't know what's going on with it. This might be a good area to start looking at to see how things are connected. One of the biggest things that it's harder for an engineer that built, whether it's a TDM or anybody's routing system, if you didn't program it, you didn't set it up, and you didn't put all the names in and know where things are, it's very difficult to reverse engineer. And it's almost impossible in the middle of the night when the power's out. So you want to, understand where things are connected, how to get around the Wheatstone system. Got some good videos in a little while. I'm going to show you that we prepared how to get around a Wheatstone system, how to do some redundancy. One of the things that we've done over the years is because one of our big sectors of Wheatstone business is television. They demand redundancy, CPUs, mix engines, lengths, Anybody out there that's trying to adhere to the SMPTE standards, the AES 67 compliance, it's just a moving target. So this stuff is basically in constant development. And the good thing for our radio clients is there's a good portion of that actually slips back down into the radio stuff. So I'm going to show you that in a little bit. But again, some of the best things that you can do for your AoIP system, buy good hardware. Buy the stuff. Manufacturers recommend equipment for a reason. They have recommendations. They're not absolute, but we do it because we have experience with it. And, like I said, I keep saying Cisco, I can't say enough about them, but if you have Arista money, what else works really well? What else do we do? HP ProCurve, one of the biggest satellite companies in America, uses ProCurves.
Yes. Arista, the Fortinet stuff we're testing with, we got some clients using Ubiquity. Yeah. So it's a variety of things. It's a good, better plan to stay with one brand. Don't try to mix Ubiquity and Fortinet with Cisco. Stick with one guy. Pick your poison and go with that.
Yeah. Again, too, many meetings for you diehard broadcasters out there. If you can keep control of your AoIP switches, I recommend you do it. I've got lots of corporate clients. I've got lots of national broadcasters where the IT department wants to take control of the network, and I get it. Understand it's their job. They want to do that. But I always ask people, does the IT guy work 24/7? Does he have a pager? Is he going to come in? Can I get into the IT rack room in the middle of the night if I have an issue? And usually we end up putting the Cisco stuff with the broadcast stuff. It's 24/7. That's what we do. So whenever possible, try to keep control over your Cisco stuff. And I used to laugh. We're going to talk about it in a minute, but you don't see a lot of updates with the Cisco. Traditionally, you did not see a lot of updates with the Cisco stuff. I haven't told people to update their Cisco stuff in years. And a few years ago, iHeart Boston, we needed to increase the stack. And this is where firmware and versions are extremely important. You're not going to run your stacked core switch on two different versions. In the case of iHeart, we were adding a bunch of studios. We need to increase the stack. So they had to go out and update their entire stack, their core switch. Well, we had obviously planned downtime for that. But that is probably the most disruptive thing that you can ever do to your broadcast facility. So for you guys that want to start out small and grow and say, well, I'm going to you might have a 20 Wheatstone studio now, Ken Wolf, Odyssey, if you're out there, and you want to start migrating over to Wheatstone. You may say, well, I'm going to do one Wheatstone studio now, so I'm just going to put an edge switch in and a core switch in. And then later on, we'll add another core switch. I would advise any client, let's build the core now. Buy the 3 or 4 switches or the 2 or 3 switches. Let's get that foundation. It's like anything that you're going to build on. You got to start with a really, really good foundation. And when you get into these core switches or the epicenter of your facility, it's extremely disruptive. So you got to plan for that. And later on, I'm going to show you how to get around that stuff. It's something that many people didn't know, but we got a few videos to show you on how you can get around your stacks. Redundancy. Redundancy is something that costs money, bottom line. And I used to see it in the big markets all the time. 20-something years ago, Jay, I want to buy an analog console. I want 2 power supplies. I want an output module, control room module, and an input module. When we went with the bridge stuff, I want a spare CPU. I need a network card. And it was the bigger guys. When it came to the IP stuff, we still followed those practices. The guys in the bigger markets buy redundant power supplies for the boards. Some of them do redundant links. Okay, so all of our original blades had a single link. So yes, could be a single point of failure. Some guys would plug that into an edge switch. They'd use LACP networking. So we would run 2 cables out of the studio, edge switch to core A or core B. And that would give them a little bit more redundancy, a little bit better level of comfort. But I was seeing that in the bigger markets. And I said, well, that makes sense. Nowadays, it's almost the opposite. If you're a small station and you don't have a full-time engineer, I'm going to tell you to buy blade fours with redundant links for our transmission. Going to tell you to build an arc, put two switches in. Let's have a plan to get around everything. So on a holiday weekend, if you take a lightning strike, you're not off for 3 or 4 days while you call somebody or you spend the money to fly your integrator in. Or again, it's a holiday weekend and nobody wants to work. So now I'm actually telling these guys that don't have engineers or have contract engineers, you're the ones that need redundancy, because in the big markets, downtime is measured in seconds, hopefully not minutes. But in the smaller markets, it's days. And by setting up your network properly, you have an A and a B path, and it might cost you 10 or 15% more over the entire price of the project. It's still a lot less than being off air for a weekend or having a dedicated guy servicing this. One of the big things, obviously, it's like your automation system. Everything's done through a GUI. Guys can remote in and get to it. But if you can build these redundancies in place where you don't have to worry about it and everything doesn't have to be an emergency, I would recommend it. So with that said, as I'm wrapping things up, I've got 4 videos that I want to show you. And if it wasn't for Janet Jackson and Justin Timberlake in the Super Bowl and then Jimmy Kimmel, they probably would have let me do these videos live. But instead, we chose to have them pre-recorded. So I'm going to move on to the first one. There's me. And what we're doing here, this is our Arcus. Okay, this is a television console. They're in most major markets around the world. And this is technology that we introduced that hopefully is going to come down to other boards in the market. But what this is going to demonstrate is 2 mix engines running simultaneously, advertising all of their audio and everything to the network with instant failover. So with that, let me take a minute and a half and show you this video. This is video 1 of 3 on the resilience of the Wheatstone system. What we're going to demonstrate right now is the dual. You might have to turn your volume up. We're not the best video guys. This is something that we worked out in Blade 4, where we can run 2 simultaneous engines for one of our television consoles, the Arcus. And what it allows us to do is we have a primary and we have a backup engine here. If I remove the A-link here for engine number 1, you'll see it actually failed over to engine number 2. This now is our active engine. The primary engine will enter a backup standby state. Network problem resolved. I can plug A back in port here. We're still on the primary engine here, which was our B, but as soon as I remove its link, we've now failed back over to engine A. I can then clear the problem. We can plug engine B back in. It will then take a standby state, and once you have an active and a standby, if you were to have another problem, let's say you have a power supply problem or it's an actual blade problem, I can simply unplug the primary blade here and you still see we have audio. So by sending coefficients from the surface to both engines, we have simultaneous mixes and everything, and they're delegated to the system. So with Blade 4, you've got the ultimate in redundant engine resilience. Cool. It works great. And for those guys that have the money to do that in the major markets, most of our television customers are going that route. Like I said, I hope that makes it down to the radio stuff. But it's just another level of, hey, we've got a 1-hour newscast. We got 1 hour to make money. It's a live show. And for a small price of an engine, like I said, I think that option is single-digit percentages in the relation to that. And then obviously on the back end of that, there's a bunch of switches and that are tuned properly for that application. So the dual redundant thing is a Wheatstone thing. All right, that's really is not adhering to anybody's standards or anything like that. That's just something our customers asked for, in our TDM stuff, everybody could have a spare mix engine or spare DSP cards. So it just seemed natural for us when we were building the big boards and TV with the IP engines to do the same thing. Now, those engines, not only do they have redundant failover, they've got 2 ports on them, which we can set to different switches. And that's what I want to talk about right now. We have a thing called hitless. Okay, and then we have a thing called AB ports. Lots of our stuff has had AB ports on, not our stuff, but most of the networking stuff in the world is at AB ports, or AoIP devices have had 2 ports. What we do is in hitless, it's a little bit different. And what we're doing with a hitless scenario is we are taking whatever audio, let's say it's a mix engine, okay? So you've got about 32 different outputs in that mix engine, and every one of those has got a unique multicast address because we've got it around the switches and talk to intercom systems and phone systems like that. So traditionally, a Blade 3's had 1 engine, 1 port. We're spitting out 32 unique multicast addresses for that engine. Well, once we went to Blade 4 and we wanted to do hitless, hitless means no interruptions, no burps, no anything. We had to create a full second set of mixes, multicast addresses. So when we look at our hit list, we are using twice as much bandwidth because I've got a full A stream of all those 32 outputs, and I've got a full B stream of those 32 outputs. And then with that, if we have a network issue or a failure or a wire bump, it will automatically use failover to the other port without a burp, hiccup, or anything. So that is what hitless is. And that is a SMPTE standard. I've got a cool little video on that I'll show you. But the other thing that we do is we have AB ports, okay? And this is for like the common person. You know, these are the Bonneville guys out there that have bought Blade 4s everywhere. We've got at least 2 or 3 core switches in all your markets. And I'd recommend that you take your Blade 4s, and we put those on your transmission paths. Port A goes to core switch 1, port B to core switch 2, all right? If you ever have to do maintenance, if a Cisco fails. And when I say Cisco fails, I'm not seeing them just getting up and dying. My big guys buy extra power supplies and stuff, but you may see a port die. And if you have these redundant things set up, it might be the difference between having to drive in that night or wait till the morning, because you have two separate paths. Now, the difference between hitless and the AB switching is it's the same set of multicast, okay? So we're not doubling your bandwidth. We're just taking all of those signals and moving them over to another port. And unfortunately, you will hear a little bump in that, but we've got a couple videos to show you now of the hitless, and then the AB port, and then the last one, which I think is pretty important. That's the Kelly Parker Zeta special that like every town square market is set up to run Cisco lists if necessary. So with further ado, there's that good-looking guy there. We're gonna we're gonna talk about the hitless switching. And hi, I'm Jay with Wheatstone, and we're here to discuss our hitless switching. This is something that we took from the 2110 SMPTE protocols. And what we have is we have a dual A and B port on our Blade 4s. Our TVE mix engines and our LXE mix engines create 2 unique streams with unique multicast addresses for all the mixes that these engines create. So if you have a maintenance window, if you had a failure, and for some reason you're set up where we've got an edge switch and a core switch, we can take our glass LXE, give it some audio, remove the A port. It has seamlessly failed over to the B port. We're still on air. There's no glitches. When we're returning from that maintenance window, or we've corrected a problem in the studio, simply bring your switch back up, plug in your A link. You'll see the system seamlessly switch back over to A, and there you have it. And that's what we call hitless switching in the Wheatstone LXC and TVE engines. It always works in PowerPoint. Hi, I'm Jay with Wheatstone, and every time it works in PowerPoint. The next thing here I want to show you guys is the AB port. again, the hitless there's no difference except if you want to do a big facility full of hitless, you're going to definitely have to look at bandwidth requirements and everything because you are doubling your AoIP system. If you're using hitless, it is truly generating a full duplicate set of addresses and signals that you're going to have to move around. Most people, I'll tell you, aren't going to do that. A lot of in around the world now, we used to see the A network, the red, the blue, and now it's purple. What I'm about to show you is probably the most real life scenarios that we'll see here. And it's basically, we've got two ports coming out of a blade and it's switching back and forth depending on whatever link is active at that time. Hi, I'm Jay, and what we're going to talk about right now in our simulated rack room is the dual network port or the redundant network ports that we have on Blade 4. It's a little different than the hitless, where the hitless is a two-stream, two full complete sets of multicast for all of the stuff coming in and out of engines. The AB switching is slightly different. Basically what we're doing is we're monitoring the AB ports that you can be found on Blade 4. So right here we've got two connections, two green happy lights. This is our transmission blade, and if I simply remove a port, 1 1000, 2 1000, 3 1000, 4 1000, it's going to automatically switch over to the redundant path on the B port. If I plug that back in, you'll see it become active again and it'll switch back. Now, like I said, it's the same stream, the same exact multicast, but we're just switching ports between A and B. It's not hitless because there is a little bit of an audio interruption, but trust me, that's more than acceptable. And in the case of a hardware failure, you're going to see that same switch over. So I'm just going to unplug switch number 1 right now. 1 1000, 2 1000, and there we go. It went over to the B switch. It'll run like that forever. So if you don't have the budget to buy 2 of everything, consider using the AB ports on your Blade 4 or on your important transmission blades. For more information, get in touch with the folks at Wheatstone. Hi, I'm Jay, and what we're going to talk. Sorry. This is the last one I want to show you guys. This is the one that will get you out of trouble in the middle of the night if you ever had a catastrophic failure, or like I said with the guys in Boston, that we need to get around the Cisco stack to do an upgrade. Hi, I'm Jay, and today what we're going to do is we're going to talk about disaster recovery or a maintenance window for your core stack. One of the biggest questions when everybody goes to AoIP and they don't see any more sound cards or XLRs hanging off the back of the rack is how do we get around a Wheatstone system in case of a failure or even a maintenance window? We weren't seeing a lot of maintenance windows with the Cisco stuff 5-10 years ago, but it seems like now as people are adding and expanding, if you're going to increase your stack, you've got to be on the same OS. So there might be a scenario where you have to shut your stack off. And if that's the case, many people don't know, but a Wheatstone blade can actually take a driver input directly to the network port and stream out. So most of us will use a transmission mixer and we'll have an A-serve or an automated automation system playing in an unattended mode. So here we've got our program audio, and in the unlikely event where we actually have a stack failure or a maintenance window, I guess the only way to demonstrate this is to pull switch A and pull switch B. Whether it's a maintenance window or you've walked in and you found your radio station in this state, well, I know right here I've got my automation system. Use a little butt connector here to splice for that. I plug that in, and within a few seconds, that multicast audio is going to be routed back to that utility mixer, and we're back on the air. Simply plug your switches in, get your network back in order, take your jumper out, and you'll be back to normal operation. Simply taking your automation system, plugging it directly into a blade will get you back on air, or it'll allow you to bypass your core stack for a maintenance window. So there we have it. We have the latest and greatest from Wheatstone. It always works in PowerPoint. You were right. Sort of like HD radio. But no, so what I want everybody to take away from today's classes are that if you don't know what you have, don't be afraid to ask. Try to keep it simple. If you don't have to VLAN everything, if you can keep it simple, you can keep a dedicated Wheatstone system and keep it on one isolated network, you'll have the best of luck. But if you're one of those guys that wants to create your own multicast network and put everything on one big network with stacking and VLANs, this stuff is meant to do it. It just depends what you're comfortable with as a user. So with that said, I only have about 45 minutes. Can we take any questions that you guys may have had during the whole presentation? Dee, can you help us with those?
Yeah, actually, there's been a couple of really good questions. And in fact, some of our attendees have answered some of those questions. And I was really impressed that they know so much about WheatNet. But Henry Harris had a really good question about updating his 8-port Catalyst 1000 switch for a bigger WheatNet system. So he's wondering, can he just copy the switch setup and program the new switch? I'm assuming not.
No, Harry, it's really easy. If you did your 8-port Cisco, just grab our document and do the command lines on the new one. They've changed. I'm guessing the 8-port Cisco is probably 10 or 12 years old.
If it's a 1000, it's probably not quite that old, but it is discontinued. So
yeah,
that'd be one reason. But yeah, get the documents offline, reach out to support, they can get it to you. Some of that's going to be in the swag bag that's there, so you'll have that information readily available to you.
Well, one question I got offline was, and I'm hoping that either Jay or maybe Kelly can answer this. What's the furthest distance you can go blade to blade? I'm curious about that. I'm sure a lot of us are.
We've got our friends down in the Cayman Islands going 90 miles under the C4 on dark fiber. 90 miles. Now, the Disney companies in New York and Connecticut have got blades at each of those locations in those cities that are on their own networks, and they're going, and that's about 80 miles between. So it depends on your network and the fiber that you have. But yeah, then we've got the guys in France, hundreds of kilometers, connecting all of their football arenas with Matty blades via remote trucks back to the head end in Paris. So France is lucky. They ran dark fiber along all the railways a long time ago. So it really depends on the infrastructure where you are.
Well, I just see that Thiago said that he ran 200 meters with a Cat 6 in Rio de Janeiro. Yeah. So,
yep.
Hey.
Yep.
So what about, tell us a little bit about, how fast a WheatNet can recover after a power outage. I mean, I've heard different stats on that.
Unfortunately, we're the least. So ultimately, if you had a UPS in your rack room, it wasn't going to power your entire rack room. I'm going to tell you, don't put the blades on it, put your switches on it. We are less than 2 minutes boot time from a cold power up for a whole failure. But where you're going to be stuck is those Cisco switches. Your edge switches are going to come up anything between 2 and 5 minutes now. But the big cores could be 8 to 10 minutes. So if you had to pick something to put on a UPS, your answer, D, is 2 minutes. But because we are just riding on the network, if the network is down, we have to wait for that to come up. And usually the most painful thing for a broadcast engineer is to watch one of those Ciscos do a cold boot.
Oh, yeah. Well, Thomas had a good question too. I'm glad he asked it. He said, do I need to switch from a blade 3 to a blade 4 to get the failover redundancy that you showed here?
Yes.
Yeah. So tell us about that.
Yeah, because it's the port. It's port count. We only have one network port on the blade 3s. And I'm going to tell you guys, we have like almost 40,000 blades out there with a single network port. That's not been a weak point for us. But as the world evolves and standards come out, we had to do the dual network ports. Nothing wrong with your blade 1, 2s, and 3s with a single port. But yeah, like I said, that stuff was television stuff that trickled down because of the red and blue network. And then again, it's blade 4, so it was sort of natural. So yes, to do that. But we do have, failover and silence detection in those blade 3s. It's not going to get around your network, but there is some type of, onboard silence detection for that blade at least.
Well, Thomas also wants to know if there's an upgrade discount.
Thomas, where's Thomas? Where's Thomas? Yes,
Let's
Thomas.
see. He's with WFU EDU. You probably know him. It's Dolan Mayer. I'm probably going to mispronounce your name.
That's right. Long as you're east of the Mississippi.
WFTD, yes, that's right.
Yeah,
WFTD.
just give us a call. We'll take care of you. But I'll tell you, nobody throws a blade away. They do not go away. People he may take that blade 3 and want to trade it in, buy a blade 4, but he'll probably find a use for that blade 3 like most people do.
Oh.
They don't come back.
Well, and that's really a good question. What is the life expectancy of a blade?
Too long. From a salesman's point of view, way too long. From an engineering view, amazing. So I was at IBC last week, and Anthony comes to me from RTE and he says, Jay, I forgot to take a picture of that blade. It's 3,000 plus days uptime. And I was like, Anthony, don't touch it. Don't talk to it. Don't spin the knob. Just leave it alone. Man, the first blades we ever sold were to Roz and Dylan. August 2008. They bought blade Alpha and Beta. 2008. They're still on air. People, when we buy parts, that's a great question. Whoever asked that is a great question, because we buy parts and we ask our parts vendors, hey, how long are these caps good for? And caps, I don't know if you noticed, their whole life expectancy is all based on heat. Most of you engineers know that, but if you run a cap really cool, it'll last forever. That's why some power supplies fail between others. Keep your caps really cool if you can. We're buying parts and our manufacturers are saying 10, 12 years. Okay. So, you talk to old timers in the industry, they will tell you the life expectancy of a switching power supply is about 5 to 7 years. We build our own supply. We build our own supply. So we're having much better luck than that. But the first generation stuff we sold is out there. And from a sales point of view, it's tough. I'm not replacing stuff fast enough.
Well, Amy says that he has an original blade from 2009 still in service. So
awesome.
So that's not just us saying that. One other question I have, Jeff Schmidt, I don't know if your question was answered in the chat box or not, but he had a really good question about connecting 2 studios that had been separated during a move, and they're each on separate VLANs. So he wants to know, how easy is it going to be? He thinks that actually the second one has a VLAN, but he wants to know how easy it's going to be to connect up those 2 studios. It should be fairly easy. I mean, from the responses that we get here. Go ahead.
It's about the IDs. Okay. Mm-hmm. So when you have VLANs, you have 2 totally different networks. So I could basically have my blade conflict on.
If the goal is to put them on the same VLAN, of course, you're going to have to make some switch changes and make sure the IDs don't conflict with the other system that you're joining it with. But outside of that, yeah, it's pretty straightforward, pretty easy.
But you want to but if they are on 2 different systems, and we've got blade 1, 2, and 3 on number system 1, and we got blade 1, 2, and 3 on system 2, they've got to change. It's really easy. You connect them together, but you would have to change those other IDs and IP addresses, just like any other basic network, else you're going to have clashes.
Well, in our next session, we're going to be talking about this a little bit, but maybe you can touch on it. Do any of these topologies that you talk about, are they more, better for remote troubleshooting, to remote in? Is one better than the other, or are they all just kind of equally?
Keep it simple.
Yeah, but as far as remote supporting it, no, none of them are really that different. You might have more to look at, more switch ports to look at to see if there's errors on, but no, for the most part, it's the same.
Okay, well, that's good to know, because I think we're going to be covering that in our next Wednesday. And I'll leave a little link here that you guys can click on to register for that, or you might want to put it on your calendar. But we're going to be covering that and a few other things too that are related to actually today's discussion. So, but we'll be back. I'm trying to think if anybody else has any more questions, or
I've got a question here somebody asked, and it was about uptimes. And I love to brag about our uptimes, but if I've got blades that have been up and running 10 or 12 years, that probably means your network has been running 10 or 12 years and it's never been rebooted or recycled. I mean, if you have an opportunity, well, let me start back up. When you get done building your WheatNet facility, Okay, we get it all up. We're going to move the guys in tomorrow. One of the best things that you can do is you can turn everything off. You can turn your core switch off. You can turn your edge switches off. Reset the counters in your switches. Then bring your WheatNet up from a brand new state, all programmed, of course, but flush everything. And that is the best foundation for anybody. Now, if you've been running your WheatNet system for 10 or 12 years, it can't hurt to find a maintenance window, reboot your Cisco switches. Also check. I would never, for my first 10 years doing AoIP, actually first 12 years doing AoIP, I never asked anybody to update switches. I mentioned that in the videos, but they are changing. They are software devices. They are human. They make things with bugs. Bugs get found. So, one of the things I might say change your practice on is keep up to date. Look at your Cisco stuff. Make sure you've got the latest and greatest. And if not, plan a maintenance window just to keep it up to date. Like I said, the stuff runs forever, but it's only as good as the stuff that it's running on. So one of the things that we've seen is we recommended to people 5 or 6, 10 years, go ahead and flush your switches. That's just good practice. Yep. Agreed.
Well, I don't know if you saw the comment on the side from Frank, who said he has 2 control room systems that are using 2960s truncated switches with no downtime since 2016. So that's
awesome.
That's awesome.
Yeah, that's some pretty good.
We need to send him a hat.
Yeah, thanks.
Got
the t-shirt.
Yeah, that's awesome.
By the
man.
way,
No,
get a hat if you register and participate or join every one of our 5 in the session here. So hats off to you, says Frank to us. So
yeah, Jeff, good question. Jeff had a question about, do we recommend the latest and greatest? I always tell everybody,
it depends on how you want to live. Do you want to live on the edge, or do you want to play it safe?
You live on the edge, you bleed sometime. And the Indians the pioneers are the ones with the arrows sticking out of their back. I don't know. If you have it's funny. It's like, when do you bleed? Yes, I unless you're having a problem it's going to fix, I'm going to say no.
Agreed.
100%. If it's just running great, and I'm not picking on any IT guys here, but years ago, I used to joke around. It's like the broadcast engineer will walk by a rack, give it a glance, say, yeah, everything's working. The younger IT guys would be there with his laptop and a console cable. Let me check out. Let me see what's going on. Let me optimize the switch. And really, if you treat that stuff like your broadcast stuff, and you walk by, you look at it on Thursday night, you tell it to behave for the next 3 days, it generally will.
Well, Magic had a question about, I know we're getting short on time here, but he wants to know if you have any recommendations, and Kelly, I think you probably can speak to this, for monitoring his blade systems, tools to use, things like that.
Sure. Cacti is a great one to monitor switches and bandwidth going between on the different ports in the switch, CPU utilization. Nagios can also, and these are all like open source things that you can download. There are some licenses as well, depending on how many devices you're going to connect. Wireshark is your friend when you're troubleshooting. If you're running a AES67 network, you have PTP. Meinberg makes a great program that's a lot like Wireshark, PTP TrackHound, that helps you troubleshoot clock issues. So those are just a few little tools like Ping Plotter. Some are paid, some are free. So it depends on what you need. There's a lot of stuff out there.
A list at the end here. We have a swag, we call a swag link, that'll take you to a couple links of documents that have some of that information. And I think we have one there that suggests good tools that you should use to monitor your system. So
yeah, you could probably find a link to John Davis's little session at the NAB that he did. That's what they talked about. So yeah, that might be helpful.
So we're going to put up a link here for the swag bag. I think it's already been up there. If not, we'll certainly include it in our webinar page so that you can link to that document. All right, I think we're kind of wrapping up here, huh? Anything else, Jay?
We are. We got an hour, but I do have a few more questions. So for those of you that need to go somewhere at 3 o'clock, I understand, but just have a couple more questions we're going to answer. One of the ones about silence detection, Fidel. We only have silence detections on the outputs. That's correct. But we do monitor the AES validity on the digital inputs, if that helps at all. So you can actually look at your AES and we will detect a loss of AES on those inputs. So that was one question. Next question from Chris. Are your plans in the future to make more systems modular like power supplies? Absolutely. if you look at the back of a Blade 4, you actually have you have a plug-in supply. You can pop the top, you can get in there and add another power supply to it. It's got another link. But yeah, and if I'm not sure if you've popped open a Blade, the Blade 3s and 4 are very modular. The 2s and 3s with a single display were not. But if you pop open a new Blade, it consists of about 7 cards maximum, and they're all connectorized. So I think you'll be pleasantly surprised if you open up a new piece of gear.
You know, Larry had a really good question too, Jay. If we have time to cover
I
it.
see this.
Yeah.
SNMP is your friend. We do have SNMP in the Blades, and so for outboard devices that we can monitor that and text and send emails, that's what we recommend to people.
Right.
I think that's about it. Does anybody else have more? Can we? Yes, Chef Key, you want links to those apps? We'll take care of you, Chef. You can also, Chef, you're 5 miles down the road. Just drive back and say hello to us. Do you have SNMP? Yes.
Yes.
Yes, we do. You can get the MIB files from our support guys. Are they on? Yes.
Yep.
If you send me a message, Matt, I will, Matthew, I'll go ahead and I'll have our guys send those to you right away. Any more questions? Wow. That was a quick hour.
It was.
All right. Well, I'd like to thank everybody for attending, and we will see you next week at class 2, I think. Anything else, Dee?
I think that covers it. I'm going to leave a quick link here to our webinar series so that you guys can click on that and register for next week's if you haven't done so already. You might want to do that now as soon as I can get it on up here. And thank you all for coming. We really appreciate it. And we'll see you next week.
All right, guys, take care. We'll see you next week. Bye-bye.
Great.